So the goal will be for us to actually recreate or create a new advection volume specific for this particle effect. So let's go to the advection volumes section. So we have here advection volumes. I'm actually gonna be caching this one out as well in a minute. Let's talk about a few things so you can understand some of the choices that I'm going to be making. And okay, the way we're going to be starting this is we're going to be getting the robot. I'm actually going to go to the dev revolve and I'm going to grab this get robot density growth, Control C, Control V. I could get the collision robot, but the advantage of this one is that it already has the rest attribute on it. Great. There's a viewport issue. It happens. So just close it. New tab, viewers, scene view. So we have a new scene view. Let's turn off lights, materials, make sure this is pinned to number 1 and hide everything else. I'm going to put the scene view back on its position. And as you can see, no more artifacts, no more bugs on the viewport. Now, the next step is going to be for us to grab this, and we want the velocity vectors to be based on this shape. But if we use this shape alone, we may not get enough variation from those vectors. So one thing we can do is actually apply a mountain. And the mountain, you'll notice, has changed quite a bit since the previous version of Houdini. Now the mountain is nothing more than just an attribute noise that's affecting position. It is zero-centered, so it will push in and push out. You do have this noise along a vector, and the vector attribute is normals, even though we don't have normals on this one, but it is creating normals on the fly. You'll get exactly the same result, just apply normals, points, either way, pretty much the same. All that changes is the visualization a bit. But yeah, this is what we have. Let's work on this noise location attribute. Remember, we'll use rest, and the element size needs to be a lot smaller, 0.02. The amplitude, let's start with 0.02. So now we have something that's um, a lot more irregular of a surface. So maybe the element size is a bit too big, 0.1, still too big. Yeah, I think this could be interesting. This might be a bit too intense, maybe 0.01. Yeah, let's give this a try. Let's animate it. Why not? Animate noise. And when I press the animate noise, he pretty much changes quite a bit, so it's no longer as harsh as it was before. So here on the fractal, let's change to standard FBM, and on the amplitude, let's go to 2, and on the size, maybe go to 0.04. Just play with it, change. The idea is that we have something happening on the surface, that it's changing a bit, so it's not just as smooth as the original shape that we have. So this should give us a lot of variation over that. Um, yeah, let's maybe even have less. We already have some interesting shapes on the model, so this might be completely unnecessary. Nonetheless, we apply it just to make sure we're doing all we can. Let's convert this to VDB from polygons, and you'll realize that we need a lot more resolution. 0.02 is still not enough to get that detail. 0.01 give us a bit more, so I'm going to exaggerate this a bit more. So we have something there, definitely. And 0.02, 0.01 is what we need to have enough detail on here. Okay, so hence the issue that actually involves the previous velocity advection volume that we were using. As you can see, this one, if you middle mouse button, you'll see voxel size 0.205. That's very different from 0.01. We want to play with these two. I want to have the same advection volume here, but I just want to make sure we have some extra velocities around the character, revolving around the character. And I'll keep using the word revolve so it makes sense. And so where do we set that up? So on the volume, when we first initially created the volume, We set the division size to 0.05, which is great. It's very fast. It updates very fast. It takes a lot longer for this to generate the trails than to actually update the volume. If you notice, you can scrub through time and it's really, really fast. So let's give it a try with 0.01. Maybe it's not that much of a difference in terms of scrubbing real time and seeing the volume change. Let's see if it is. It's quite different. No longer scrubbing. That's not an option. So in this case, what I'll be doing is I'm actually going to be caching this volume. So let's create a file cache, labs file cache, and let's go here. Let's give it a try with 0.02 if that's enough. That's better because 0.01 seems a bit too much. Let's see if this updates better. Okay, still not real time, but at least doesn't have to wait for it. So it's a bit better. Let's go with something in between. So it's not 0.01 like we wish we could have, but let's go with 0.02. Seems reasonable. Let's cache this. I'm going to show you one small trick that you can use when you're working with, if you have specific locations for some things, or if you just want to create your own little variables that you can use globally in your file. You can use something like the context options. So you have here context options and you can create your own. I'm going to create a file path and I'm going to say that this is going to be called Sims cache. This is the name of the variable and the location is actually going to be, I'm going to look for the location. Okay, so I find that hitting accept doesn't actually work. So what I do is I just copy the path here, Control C, hit cancel and paste it here. Okay, that seems to do the trick. So we now have that variable and I'm going to show you what that means. It means that if you go here, instead of using these variables, you can use your own. So I'm going to use Sims cache. Of course, this won't work. If you middle mouse button on this, you see that this doesn't resolve into anything. You need to actually add those little ticks so that it backticks so that it actually resolves into what it should. Okay, so if you want to add something, so in this case it's going to be Advection Volumes, and then it's going to be based on the name of the operator, which I'm going to be calling val A. I'm going to be saving this to disk. This is not a simulation, so you can actually turn this off, and that way it's going to be able to use several threads to actually cache this out. It'll be faster. Press save to disk in background and just wait for it. Before caching this out to disk, let's do some optimization into our volume. So instead of, right now we have 3 float volumes, and instead of having volumes, I'm gonna convert this to VDB, convert, apply all types to VDB. So now we'll have 3 VDB floats, 3 VDBs. Then you have something called vector merge, and it's no longer called vector merge, it's vector from scalar, which makes sense. Now, if you middle mouse button, you'll see that you no longer have 3 float VDBs, you have 1 vector VDB. Okay. Further optimization you can do is nothing like this. Let me push this down. And what we can do is type primitive, and again, no longer primitive, it's called primitive properties. Hit enter. Let's place it here. And with this primitive node, what you can do is go to volumes, and on the VDB, select the vector type you're working on, and it's going to be displacement, velocity, acceleration, and write it into 16-bit floats. This will be enough, and this will save us some disk space. And now we are definitely ready to go. Just press save to disk in background, and you'll be good. Let's see. I already have it cached, so I can actually scrub through it really well. But that's the process.